year student here at UCI. I do theoretical particle physics. My co-advisors are Professor Michael Ratz and Professor Irvine. And today I'll try to explain to you, as I will explain to a third grader, the project I'm working on, which is basically something called Qballs. Now, it might sound intimidating at the first sight because you might never encountered this topic before, but I'll try to simplify it as much as I could to give a general idea about this project. So basically, I'll start by talking about how do physicists generally view nature, and what are the methods they use to understand different systems around us, whether it's a single particle, system of particles, a car, a ball rolling, and we understand these systems with something we call differential equations. So for example, if we want to understand how a ball rolls to this position, this can be described with something we call differential equation. And the differential equations are equations that describe the evolution of these systems, and that's the bottom line in any physical system we're trying to understand. So how does this connect to Qballs? So because I work in particle physics, we're interested here in the department to understand what exists in nature. What kind of particles? What are the charges of these particles? Are there only particles, or there are different objects that live in space and time? What's the nature of the space and time? Masses, charges, all of these parameters that can describe nature. How do these particles interact with each other? How we can probe these particles to take them from a certain energy to a higher level energy. We call this exciting a system. So that's basically what we call, that's basically stuff we are interested to understand while studying nature. So Qballs happen to describe something called solitons. It's not important what solitons are. However, Qballs are interesting because the name ball comes from the fact that Qballs are a spherically symmetric object, and these spherically symmetric objects have a charge, and whether it's a positive or a negative charge, it's not important, but let's say, for example, it's a positive charge, and every Qball has a charge, and this charge is directly correlated with the number of particles that which build up this Qball. So basically what we try to do in our project is to understand what Qballs are, how can we find a differential equation, which is basically, as we said, how these systems evolve. We try to find differential equations that describe these Qballs, and by understanding these differential equations, we can understand the charge, the mass, the energy of these Qballs. And our latest research, or our latest efforts in the next paper, hopefully that we will get published soon, we try to understand how do these objects look like when we probe them, when we take them to a higher excited state. So that's something we're interested to do lately. And also, there is another mysterious particle that lives in our universe. We call it dark matter. These are particles that exist all around us. We know that because they have gravitational effects on other particles. However, they interact very weakly with the particles we know. So we don't know the nature of these particles very well. So Qballs happen to have some features that could be interesting to be understood in light of dark matter. So the latest stuff we're interested to study are what happens to Qballs when we probe them with energy and take them to other excited states, and we want to learn how their differential equations change and how can we use these our mathematical methods to understand the nature of the Qball. And then we are hoping to extend our research to a possibility to find a connection between Qballs and dark matter. And that's basically what my research is, and I hope that I was able to explain it for a third grade. Thank you.